So now we're going to move on to similar polygons. And if you didn't know what a polygon was, let's go over the definition. So a polygon is a closed shape with straight sides. So a triangle, closed, straight sides. A rectangle is a polygon, closed, straight sides. A square, that's not a very good square. A diamond, a hexagon, 1, 2, 3, 4, 5, 6, etc., etc. So what are some shapes that are non-polygons? Well, a closed shape that doesn't have straight sides would be a circle. That's not a polygon. A heart. So one that kind of meets the definition of closed with straight sides, I call it the evergreen. This is not a polygon, and the reason is, part of the definition of a polygon is you can't go from one part of the polygon. I'll use a different color pen here. You can't go from one part of the polygon and to another and go outside the polygon. So that's why this fails. If you look at any of these polygons on the left here, no matter where I go, you know, it'll automatically connect inside. You can't go outside and then back in. So I just want to switch back to my purple. I like purple. Okay. When one polygon is an enlargement or reduction of another polygon, we say the polygons are similar. Similar polygons have the same shape, but not necessarily the same size. When two polygons are similar, two properties must be true. The matching angles are equal, and the matching sides are proportional. When all pairs of matching sides have the same scale factor, we say the matching sides are proportional. Okay, it says here, are these quadrilaterals similar? Justify your answer. So when you do this, you have to compare the corresponding sides with the corresponding other sides. So first off, we have to make sure that all of the angles are the same. That's the first property. So 135, 135, 45, 45, and then the other two are 90. So all the angles are equal. So all angles are equal. So that is true. And the second thing we have to do is we need to see if the scale factor is the same. So I need to figure out the scale factor. So in these type of scenarios, you don't know which one you would consider the original. I like always putting the bigger number on top for when I'm finding the scale factor. So I'm going to say this one is the original and this one is an enlargement. So I'm going to check. Let's see the scale factor. This one is, I'm going to compare 4.2 divided by 2.8, and I get 1.5. I'm going to compare 1.5 to 1, I get 1.5. I'm going to compare 3 to 2, and I get 1.5. I'm going to compare 4.5 to 3. Oops. And I get 1.5 as well. So all of these are the same scale factor. So all sides scale factor are 1.5. So the quadrilateral is similar. It met the two properties. So how do we actually state that? Well, I'm going to go from alphabetical QRST. I'm going to start with the first one, QRST, is similar. So that symbol right there means similar. One little squiggle, enya, whatever you want to call it. Now, here's the thing. When I state QRST, I need to do the corresponding order on the other one. So for instance, Q corresponds with the U. So I got to start with the U. Do you see the Q and the U are in the same spot? Then the R and the V. Oops, I put R. Then the S corresponds with the W, and then the leftover X. So do you see, when you go from Q, Q corresponds with U, R corresponds with V, S corresponds with D, W. Sorry, so the Q corresponds with the U, the R corresponds with the V, S with W, and T with X. Okay, moving on. So are these similar? So these are both rectangles, so all the angles are the same. So all angles are 90 degrees, so they're all equal. Okay, the next thing is to figure out the scale factor. So again, you can only do lengths to lengths. Like, don't compare a length to a width. So, and I'm going to do this as my original, and this is an enlargement. So my scale factor is 8 divided by 5, and I get 1.6. Then if I do these two, I get 5 divided by 2.5, which gives me 2. So you can see they are not the same scale factor, so not proportional. What happened here, it looks like, is you know, somebody maybe didn't drag from the corner so that the length and the width were getting enlarged at the same rate. So that means, therefore, not similar. Okay? Next up, are the parallelograms similar? Justify your answer. So now just look at all the corresponding angles. They're all the same. So all angles same in the corresponding spots. Now we need to do, it's kind of like a rectangle. You have a longer side, so I'm going to do a length compared to a length. I'm going to say this is my enlargement, this is my original. So 3.0 divided by 2.25 gives me 1.3 repeating. And then if I go that way, I get 2.0 divided by 1.5, and I get 1.3 repeating. So they are the same scale factor. So now, again, remember, I got to put this in the right order. I'm going to start with M, go alphabetically. M, N, P, Q is similar to, and because I started with the M, this is the corresponding part. So that's E, F, G, H. So that is how we write it. All right. Example 4, are these two similar? Oh, sorry. They're not asking if they're similar. They're saying to find JM. So in order to do this, essentially, is the corresponding sides, because they state that they're similar, that means the corresponding sides are proportional. So again, I'm going to make this my enlargement, this my original. So they're trying to say, figure out what that is, that length right there is. So does everybody see that this 20 corresponds with the 8? So I'm going to put 20 over 8, and I get a scale factor that way. That should be the same scale factor as 16 is to JM. So this is a setup for cross multiplying. Do you remember how to do a cross multiply? Do the switcheroo. So JM is going to be 8 times 16 divided by 20, and I get 6.4 centimeters. Moving on. Example 4, these two are similar, find JK. Well, again, if they're stating that they're similar, so you don't have to test it, they've told you. And again, this corresponds with this side. So JK right here corresponds with that. So I'm going to make this the enlargement, this the original. So 3.6 divided by 2.4, because they're the same scale factor. Again, if I start with 3.6, I got to start with JK then. JK, because that's on the same pentagon, JK over 1.6. So we do a cross multiply. 1.6 times 3.6 divided by 2.4. And we get JK is 2.7 centimeters. All right, let's keep going. Set up these proportions. It's saying they're similar. That means they have the same scale factor, which means you can set this up again. Here's enlargement. Here's my original. This corresponds with this, and this side right here would correspond with this side right here. So 3 divided by 1.8 is the same scale factor as 2 divided by YZ. So do a little cross multiply. YZ is going to be 2 times 1.8 divided by 3, and I get 1.2 centimeters. Again, if you want to try this on your own, you can pause the video and then check your answers. So this corresponds with this because it's saying it's similar, which means this side is going to correspond with the UV. Again, I'm doing enlargement original. So 2.1 divided by 1.4 gives me a scale factor, and then I need to figure out the other scale factor setup, which is UV over 3.4. And because the scale factors are the same, I can do a cross multiply and go 3.4 times 2.1 divided by 1.4, and I get 5.1, and that would be centimeters again. Perfect.